As we continue our titration of this 0.2 mole per litre ammonia solution with our 0.5 mole per litre hydrochloric acid solution, we would expect the pH to continue to fall. So after the addition of 5 mils of the acid, we were in the buffer region and we computed the pH to be 9.6. So now we're going to add another 5 mils of the acid, taking the total addition up to 10 mils, and we'll compute the pH again. It should be a little lower than what we had before. So let's give this a go. The first thing we want to do is we're going to take our ammonia and we're going to add our source of H+ to it, generating our ammonium ion, and we need to calculate the concentration of the components of our weak base and its conjugate acid. So we'll start right from the beginning. Initially, we're going to be working in moles to do this, by the way. I should write this out. Always in moles when you do this initial calculation. So what do we got? We got 40 mils of ammonia, and the concentration was 0.2 moles per litre. So 1 litre is the same as 1,000 millilitres. So we'll just kind of make this 1,000 millilitres. So there we go, 40 times 0.2 on 1,000. And that means that we got 0.008 of that, 0.008. Okay, now how much acid did we add to that? Well, it was a total of 10 mils. So we go 10 mils, and the concentration of it was 0.5 mole per litre. There we go. So there we go, 10 times 0.5 on 1,000. And that is 0.005. So that's going to be 0.005, and this will be 0 to begin with. So our acid will be our limiting reactant, so this is going to go down by 0.005. This will go down by 0.005, using up all of our limiting reactant. So at the end, I've got 0.003 moles of my ammonia, none of my strong acid, and this, my conjugate acid, would have gone up by 0.005. So I'd have 0.005 of that at the end. So after the addition of 10 mils of my strong acid, what do I have? I have a solution that is a mixture of a weak base in the presence of its conjugate acid. So I can solve for a mixture of a weak base and its conjugate acid. I can solve for the pH using the Henderson-Hasselbalch equation. And I actually have everything that I need to do this fairly promptly, because I had previously calculated the pKa of my conjugate acid of my ammonium ion. So the pKa of ammonium is equal to 9.255. So putting it all together, pH equals 9.255 plus log of, and my moles of my base, that's my moles of ammonia, it was 0.003, and then the moles of my acid, that's my moles of ammonium, 0.005. Let's see what we get there, 9.255 plus log of 0.003 divided by 0.005, and if we're lucky, it should be a number that is lower than what we had before, and I got 9.033. So just compare, yep, it's continuing to head downwards. So we're just, yeah, it's looking good there. I'm happy with this.